Warning: engineering content. Few minutes of engineering. Role of the main compounds in hydration. The major compounds that react during the hydration of cement are dicalcium silicate C2S, tricalcium silicate C3S, tricalcium aluminate C3A, tetracalcium aluminoferrite C4AF, and gypsum. The amounts of these compounds and how they react affect the initial and final properties of during and after the hydration process. Tricalcium aluminate. Although the amount of tricalcium aluminate in cement is relatively small, it has a major effect during the hydration mechanisms. The reaction between this compound and water is very intense and highly exothermic, producing hexagonal crystallized calcium aluminate hydrate. This reaction can cause rapid setting in a mixture, also known as flash setting, if kept uncontrolled. Thereby, a set controlling agent is used, gypsum, which is added to clinker during the final cement manufacturing process. Tricalcium aluminate is not desirable at high quantities since its reaction is highly exothermal and it interacts with water or soils containing sulfates. Gypsum. The main role of gypsum is to delay and control the intense reaction of tricalcium aluminate with water in the hydration process. Gypsum reacts with tricalcium aluminate, forming an insoluble calcium sulfoaluminate compound, ettringite, around the tricalcium aluminate particles, thus delaying and controlling reaction. This phenomenon not only affects the workability of a mixture by controlling its setting time, but also gives enough time for the tricalcium silicate reaction to initiate. The reaction between gypsum and tricalcium aluminate continues until one of them is depleted. During this time, the tricalcium aluminate reaction is still in progress. The amount of gypsum used in cement is crucial during the hydration process. If tricalcium aluminate is depleted before gypsum, the excess amount of gypsum remained expands, causing cracks and reduced durability. Whereas, if gypsum is depleted before tricalcium aluminate, the surplus amount will eventually react with the unstable ettringite to form monosulfate aluminate hydrate crystals, which negatively affects the durability of concrete subjected to sulfate attack. Tricalcium silicate. The tricalcium silicate reacts to produce calcium silicate hydrate gel, calcium hydroxide, and heat. This reaction is considered to be moderately exothermal, having a rapid rate, and mainly responsible for the early age strength of concrete. The hydration of tricalcium silicate affects the strength of the hardened concrete for about a year. Dicalcium silicate. Dicalcium silicate, like tricalcium silicate, reacts to produce calcium silicate hydrate gel, calcium hydroxide, and heat. However, this reaction produces less calcium hydroxide amount compared to that of tricalcium silicate. In addition, this reaction has a much slower rate, generates less heat, and it is considered responsible for the long-term strength. Tetracalcium aluminoferrite. The reaction of tetracalcium aluminoferrite is somehow similar, but slower, than that of tricalcium aluminate. This compound also helps in accelerating the reaction of silicates. Its reaction is considered to be moderately exothermal, having a very rapid rate, and helps in resisting chemical attacks. As a summary of the characteristics of the main compounds in cement hydration, C3A has an instantaneous reaction, very rapid strength development, high heat generation, and very low resistance to chemical attacks. C3S has a rapid reaction rate and strength development, moderate heat generation, and low resistance to chemical attacks. C2S has a slow reaction and strength development, low heat generation, and moderate resistance to chemical attacks. C4AF has a rapid reaction, very rapid strength development, moderate heat generation, and high resistance to chemical attacks.